Hi, welcome back to Networks and Security. Today we're going to actually see a video of me crimping the tip on the end of a cable. Now, I did not have a battery, so I couldn't test my cable, but hopefully it worked. And so stick around till the corner or the end of the slides there, and you'll see that. The other things we're going to cover are networking tools. So let's go ahead and get started. So this is Chapter 11. So if you're following through with the Network Plus book, and you are getting ready for the Network Plus test, which of course my quizzes are Network Plus. I'm using the same test bank there. So if you're doing that, this is Chapter 11, Network Management. So let's go ahead and look at physical maintenance tools, configuration management, documentation, monitoring resources, and reports. Managing a network. What are some of the more common tools used to physically maintain a network? What components are involved in configuration management? What sorts of management network monitoring tools are available to network administrators, and what types of information are included in various logs? Now, maintenance tools. Many network problems can be reduced through proper installation and configuration. That's probably the biggest thing right there is if you do it right the first time, you usually don't have to go back and fix it repeatedly in the future. This has proven to be extremely effective with consulting. Yeah, often you'll be called into a network that's been really poorly done. And so your consulting bill will be, hey, we're just going to reroute everything. We're going to put everything at 45 degrees, everything at 90 degrees. We're going to make everything very neat, very accessible, extremely manageable. This is not about cybersecurity here as far as obfuscation. In this case, what we're looking at is making everything easily visible, easily maintainable. If you'll do that, you'll never have a problem again. So get someone who knows what they're doing when you do the installation. And if you are called into a place where they did a really bad job, then go through and get someone to do a really good job to fix that up. So moving on. Multiple hardware and software tools are available to help diagnose, isolate, and resolve those issues. So cable tester tests the conductors and Ethernet cable, verifies continuity for each wire in the cable and the pinouts of the connectors. I think that's actually the same one I have. Look at that. All right. A cable certifier is different from a cable tester. A cable tester is going to just let you know if you have continuity. So that is just if there's a circuit there. The cable certifier is actually going to send actual packets, data through the cable and let you know if this is going to be a really high quality connection or a low quality connection. Any of your good cable companies are going to have cable certifiers. These usually have a little printer and they can print out the certification, or they'll send you an email and that'll show you the certification there. So moving on down, bit error rate tester, BERT. The bit error rate tester generates bit patterns at one end of a link, intercepts the bits at the other end, analyzes the received patterns for differences. The result is a percentage measure of the bits that were incorrectly received, known as the bit errors. Now, this is getting a little different, and you'll notice you're not looking at a majority of Ethernet connectors on that right there. So these are things that you might see in a video production company or at a large core data center or something else. Usually you will not see this. Whereas I was saying that any good quality will have your cable certifier there. The BERT, the bit error rate tester, is not something that you'll run into very often. So here, connectivity software. Of course, there's remote desktop connection, MSTSC. This is going to be a RDP connection, remote desktop protocol connection. So there are a bunch of them out there. We actually use real VNC in our lab. GoToMyPC is really popular. Join.me is very popular. Of course, talked about Microsoft right there. And cloud-based options are also gaining in popularity here and there. Join.me is fantastic. It's easy to use, easy to make a connection. Just really, really fantastic option. GoToMyPC was purchased by another company, and it became a little more complicated to use. Crimpers. You'll need a crimper if you're going to be doing network cabling. A crimper is a tool used to attach a connector to the end of a cable. This allows you to make your own cables of non-standard lengths. Now, there is no standard length that I know of. A lot of people are like, oh, that's a 6-foot cable and that's a 2-meter cable. Yeah. So when you're talking about lengths, usually you go in and every supplier has what they call a standard, and that's what they produce. And then, of course, most places will produce different length cables for you anyway. Now, another thing that you're going to need is a Leatherman. So you do need a Leatherman when you're doing this. Let's see if I've got one sitting right next to me. It's actually upstairs where I just did the video. Yeah, so I did the video upstairs, and of course I had my Leatherman with me. Any network guy, any network gal is going to have a Leatherman. I know the Gerber people out there are like, what about Gerber? Yeah, okay, fine, maybe that too, but a Leatherman, that's where you got to go. So electrostatic discharge, ESD resistor, one of those things that you don't usually use when you're working on network cabling. If your cables are connected, it's low voltage, and it's not something that if you're actually going in and moving cables around, you're not worried about electrostatic discharge. If you are working on a system that is under extremely high requirements, let's say really under a lot of pressure, and it is at 100 gigabits or something of that sort, then maybe you can bring this kind of thing in. But really, if you're running that kind of network, you should be using the proper cables with the proper shielding. Environmental monitors, these will let you know if you're too hot, too cold, unlikely, but too cold, too wet is another one, etc. So watch out for those. Loopback plugs, these are little loopback. A loopback plug can test the network interface's transmit and receive functions. So as it transmits, it'll receive it right back into the loopback. It does this by connecting or looping the transmission wire to the receive wire as seen as Cat5 and fiber examples below. So the reason you have two fiber optic connections on each of your wires is because one of those is a receive and the other is a transmit. So that's the reason those two are there. And then on an Ethernet plug, you'll have two wires that go for the receive and two wires that go for transmit. So those are carried back and forth. Two connections, I guess you should say. Alrighty. Multimeter. If you're testing continuity, that's fine. If you really want to get down and test some type of resistance, I guess you could. But this is one of the things that you probably are not going to need to test the network. This is if you run into a situation where you don't have a continuity tester, then a multimeter might work out for you, but the chances are it's not going to help. Protocol analyzer is software also known as a network sniffer. Inbound, outbound data can be captured from a network interface. Reviewing the data means to look in the protocol header fields for abnormal information. There you go. The analyzer can be a standalone device, but is usually your software running on a laptop computer. Wireshark is an example of a software-based protocol analyzer. And of course, we use TCP dump as it's much more efficient and faster that you can scroll it right up the screen and it's easier to use. There you go. This is an example of Wireshark. Wireshark is a fantastic utility. Prefer TCP dump in almost every case. However, Wireshark is very useful when I'm breaking down protocols and reconstructing an entire transmission. So punch down tools. This is, if you're looking over there, you got a 110 blade in that one right there. And that would be for a 110 block. So that's how you punch that thing in. Throughput tester. A throughput tester is a network appliance that typically has multiple network interfaces, can generate high volumes of pseudo-random traffic. It's used to test the proposed network equipment, proof of concepts, to see how it works under load, and existing production networks determine the actual throughput of the existing network there. So at this point, let's go ahead and flip over and look at how we would use these tools right there, the punch down and other tools, to test our cable and the way we're putting all that together. Hey, welcome back. So we're going to look at network cabling today. We're going to crimp a tip on here, and hopefully that we can get focus on this right here. So while we're doing this, so this is a network cable, and I went ahead and I sliced off the insulator, and I've started to untangle the little wires inside of there. So if you cut off, like this would be too much, of course, to go in here. You want the insulation to be right there in the back of this. So you do want the insulation to be present right there. So let's go ahead and get all this untangled, all these untwisted, and let's get started. Now I will be using 568B because B is the most common in the world. Well, I'll say the United States. And 568 just stinks. No, I'm kidding. 568B is great. And that's probably the tip over here if you could see that tip and see the different colors in there, we'll see that this is actually using 568B. We got the brown, brown and white, green, blue and white, blue, green and white, then orange and white. So I wish I could have a focus on this right now, but we'll see if I can pull something a little bit closer. Maybe about like that. Okay, so we'll just take this and go back to this first portion. So this first portion here, we're going to go ahead and separate the brown, brown and white. Then we're going to go over green, blue and white. If you can get it all sorted out. And then blue, green, blue and white, blue, green and white, orange and white. So once you get it broken down like that, then we're going to go ahead and twist and pull these together. If you see that during the twisting action here, that it actually comes together naturally, and it starts to really line everything up nicely as we twist it. I'm going to try to break this out a little bit better there. So this is twisting. What I'm doing is holding up my fingernails, and I'm twisting back and forth just like that to make it all level out. So we've got the brown, brown and white, green, blue and white, blue, green and white, and orange and white right there. So now I've got that out. I'm going to go ahead and grab my crimping cutting tool here, and I'm going to snip that off. So snipping it off gives me a nice flat edge. So you can see the edge there. You flip this upside down. So if you're looking at that clip at top, we're going to use the underside like this. And we're going to put that underside just like this and just feed those into that RJ plug. All right, so I think we've got it. All right, once again, if I could get a focus on that, that'd be cool, but I don't think I can focus that close here. So we'll just have to say, oh yeah, that's great. Okay, so there we go. All the cables are in there now. So everything went across. We can see from the brown and white, brown, brown and white, green, blue and white, blue, green and white, orange and white. Now what we do is we take our crimping tool and we'll pop this right there, and we will crimp that thing down. So now we got that crimped down. We'd use a cable tester. Now this is a simple cable tester. All this does is actually breaks down whether or not we have connectivity. Now this case is not going to do anything because I have a battery in it. But you would get your cable tester, and then you would plug in both ends of the cord into the cable tester. That is how you crimp a new tip onto an existing wire or create a new wire. Of course, if you're creating a new wire, just take both ends and put a tip on both ends. Be sure you line up all of the wires inside the cable the exact same way. So if you're using the 568B, which of course I recommend, then you got the brown, brown and white, green, blue and white, blue, green and white, orange and white. You've got all that in sequence on both sides. I hope that this helps, and I look forward to talking to you again in the future.
Okay, welcome back. So Throughput Tester, this over here is an example of a throughput tester. It's going to go through and it's going to give you some type of an idea of how much traffic can go across your network. So time domain reflectometer or optical time domain reflectometer. This is used for either copper or for fiber optics. For the copper side, of course, it's just a TDR. For the fiber optic side, of course, it's the optical TDR, the OTDR. Okay, toner probe. This is also called a fox and hound or a probe, whatever, a toner. This over here, a tone generator, is the little thing that makes the noise, and the probe is used to find it. So what you do is you hook one end up to the wire, and then you find the other one by just holding that little probe against it, and you'll hear it go like that as it finds where the tone is. And so then the closer you get and the better it gets. It's like, and so you get that whole tone out of it. That kind of thing. Oh, in fact, there it is. That's a fox and hound. Look at that. That's the hound right there. Hound 3. Anyway, those things right there are useful when you're troubleshooting, trying to find out where a cable goes, which unfortunately is a common problem. A wireless spectrum analyzer. There are several different wireless spectrum analyzers. They can cost in the range of $60,000. You can buy them for about $199 for your computer. But if you're looking at real wireless spectrum analyzers, then they're going to measure everything from I don't know, extremely low, maybe down in the hertz, up to 70 gigahertz. It's going to be a full spectrum. So mostly what you're doing for wireless here is you're looking at something that's going to go from 2 up to 6, and that's it. A lot of people won't even go that far. So parses out the various wavelengths and used by SSID, useful to doing wireless network planning. So configuration management focuses on maintaining up-to-date documentation of network configuration. Let's see. Procedures in CM include the following: asset management, baselining, cable management, change management, and network documentation. Monitoring resources and reports. Examples of monitoring resources and reports include the following: Syslog server, simple network management protocol server, event viewer logs, and network cipher packet captures. Simple Network Management Protocol, SNMP. An SNMP manager can send information to SET, request information from GET, receive unsolicited information trap from devices such as routers, switches, and servers that are triggered to look for specific types of data. So if you're looking at SNMP, it can send a whole bunch of stuff. It can send case temperatures, CPU temperatures, of course, the name of the device, and just a whole lot of stuff. So if you're interested in that, there is SNMP Walk, and that's a Linux utility. You can go look at those. You can also look at all of the numbers and everything associated with SNMP. That gets extremely complicated. So it's something fun to check out. So you got version 1 and version 2. Version 1 is fine for almost every case. They talk about you'll need version 3, where actually, let's see. So over there, version 1 and version 2C use community strings to gain access to a device. If left the default community strings of public, read-only, or private, read-write, devices could be compromised. All right, that's if you have private enabled. That means you're allowing remote writing via an SNMP, which is extremely uncommon unless you're just managing a whole lot of network devices. And if you're managing a whole lot of network devices, very possibly using SNMP to roll out those changes. And these would be to non-intelligent network devices, Cisco routers, or if you're using a bunch of switches, Juniper stuff, or webcams. You can just log into those and usually make all the changes. You don't need to enable any type of read-write access to the device. So having just a public string and allowing SNMPv1 to run is usually the best way to go. It's extremely efficient. There's no risk of anyone compromising their device, and there's no risk of you losing a username and password. Whereas SNMP via version 3 says addresses these weaknesses by creating additional weaknesses, and that is authentication and encryption. So the integrity side is saying, oh, okay, well, SNMP is actually running over UDP. So, well, when we run that over UDP, we don't have a whole lot of integrity in the line. So they're implementing an integrity control. Authentication, which means now you can type in your username and password and potentially give them to hackers, because why would you send your username and password over SNMP unless it's a large network with those devices? And then encryption. So now you can have devices sending traffic on your network that you can't see because it's encrypted. Only use encryption where encryption is required. Try to avoid using encryption in every other case. So over there, they're breaking down SNMP version 3 entities. I'm not a big fan of SNMP version 3, if you could not tell. So there you go. Syslog rocks. Syslog sends all of your logs locally as well as to remote systems. So the good ones to look at are Syslog, Syslog NG, and rsyslog. So you can check those out in systems. Sample Syslog clients, of course, is just any system sends Syslog over to a server and we record it. That's what we use over at Geneva and the Cyber Lab on the wall. That's a Syslog server, and I've got the systems just sending Syslogs over to it. So the security levels over there, we've got the 0 emergencies, 1 alerts, 2 critical, 3 errors, 4 warnings, 5 notifications, 6 informational, and 7 debugging. So it just sends everything over. Now, it is important to know that the client and the server, but mostly just the client need the ability to send that level of information. If you've got a system that can only send a certain level, that's all it'll send. So if you're looking at warnings, notification, or anything else, then debugging, your client has to support that. Structure of a syslog message over there. They're using Kiwi syslog, which I recommend against. I say that you should use your Linux and Unix command line utilities. Then you can do everything that you could ever want to do. It's free, it's fast, and you can tail-F watching your syslog live. So if you're using Kiwi, then that's just like it's a crutch. You know, it's a crutch for people who don't have the skills to use Linux and Unix systems. So over there, logging, inside of Windows, you got application logs, security logs, and system logs. You have more than that, but those are the 3 primary that you'll see. So on the application log side, this is how Windows breaks it down. It makes it rather difficult to read on that version of Windows. It makes it really hard to go through, filter out what's going on in the network, and find real-time what's happening. Same with the security log, and the same with the system log there. So it makes it very difficult to go down and correlate events. So Windows is probably the leading reason that something like Splunk was developed, and that's because it's just really bad at logging. What you want to do is take those logs, dump those out to another system. You can use a bunch of different free syslogging utilities, or you can actually grab the EVTs and convert them, bring them over to a Linux system, and then use the hundreds of command line utilities that are available to you for data analysis and text processing that are used at 100% of the supercomputing systems of the world and are used at well over 99% of the scientific systems of the world. So the Linux and Unix utilities are not obscure. They are the most popular utilities in use today. It's just most people are really devoid of knowledge of how to use those. You're not. You know how to use them. Remote access methods, again, with virtual private network software, whatever you're using for that. Remote desktop protocol, which is like MSTSC, the Terminal Services Client. Virtual network computing, which is the VNC client. Secure shell, SSH. Telnet, which is, of course, telnetting into a system. Telnet is not secure. And if it requires your username and password, then you are giving away your username and password. HTTPS, of course, just logging into a site in a secure manner. That way everything is encrypted from your source to the destination. And then file management, where you have FTP and FTPS, which SFTP is probably the most common, and that runs over the same thing as Secure Shell Port 22. So, quick recap. You can look down through that, the things we covered in this message. This one went a little bit long because of the video discussing how to make the cables, but I hope it helps. And if you want to leave me some comments and let me know more things that you'd like to hear about, great. I'd love to hear them. And I look forward to seeing you for the final exam, which is next week. So please stay tuned for a message about the final.